Why were you smiling then?
All right, we gotta roll, guys. It's already 7 after. Should you guys just not sit next to each other? Yeah, maybe that's the idea. I don't know what's going on, but it seems like there's something. All right, we gotta get rolling because we again today need to cover 2 lessons. So please make sure we all have a shape template, at least one to share. We might run out. We might have to share. Back in my day, I kept a quarter in my binder so I could trace circles because I sucked at drawing circles. That's not cheating. That's using your resources.
You have some right here.
What? Oh, I found that for you. I found that in one of my binders yesterday, so I put it out just for you. I'm not joking. Yeah.
So, if using a quarter is using our resources, then how come we can't look up answers?
That would be using your resources. But we're not testing can you use your resources when we get it. Can I respond?
Yeah.
We're not testing automatically can you use your resources. We're testing have you learned this material. I'm not testing can you draw a circle. That's not what I'm testing you on. So feel free to use a resource to get to that perfect circle. Does that satisfy your answer, Joey? Or your question? Yes.
I was going to tell you more, but then last night I left all my stuff before.
Okay. Are you going to be able to get it back?
Yeah.
Okay. Let me know if there's an issue.
When my math homework's all done, it's just
Everything, your binder.
my binder, my coat, my...
Dude, how did you leave everything? That's
I had
unfortunate.
a track meet until 8 o'clock last night, and I went and...
Wait, you guys are already having meets? I don't have them on my schedule. My schedule starts at April. I know, but like, oh yeah, I guess. No, the first one I have for you guys is April 4th. But okay, we need to talk at some point, is really what that means. I need to make sure that I know when to come and see you guys. Because I need pictures for your book. Alright, now if you haven't heard yet, Natalie and I at some point are going to have a throwdown.
Oh.
We're going to have a tennis throwdown. Now, fortunately, this is already part of the lesson, but I'm starting to actually get a little nervous. Apparently, Natalie's tennis coach once taught Serena Williams. So, our lesson today, if you want an easy header, just make your header circles. Just make your header circles if you want. You can write circumference, diameter, and pi if you want. But you could make your header circles if you want. I have a question for you. If we're looking at design, right, and we're trying to design a new label for our can of tennis balls, we're going to need this label to wrap all the way around. Because unless you're going to use like an excessive amount of glue, most of the time labels are made where the sticky is on part of the label, it wraps around, sticks to itself, and you're good. So we would need to know the entire distance around this can, right, which I can tell is bigger than whatever the distance is that I can wrap with my fingers. But how do we think that would compare to the distance across the can? So like one of the guys on the design team was like, well, we can measure the can, but he has like a straight metal ruler, right? Like what you guys had yesterday. So, you know, he goes and he tries to measure the can and he starts to try to bend the ruler around the can and Mr. Padilla pops out and he's like, don't bend the rulers! So we got to figure out how we could determine this distance around the can when we can only measure a straight distance.
Use that tape.
We don't have that. All we have are straight metal rulers. So I want you and your team to make a prediction, and I want you to write this down. If we knew the distance across, actually, so draw a circle on your paper. Use your shape template. Go ahead and draw a circle. You can pick the size, but you want it to be big enough to write on. Then, draw a line across the circle. And draw a line from the center of the circle to the edge. Yes.
What is it called when it's a circle but it's not a circle because it has 10 sides?
Because it has what?
Not a circle.
10 sides.
A decagon?
What?
Yeah, the prefix just tells you how many sides. Dec means 10. So we want to remind ourselves of these names before we start trying to talk about this. So we said that this guy in the meeting, not the brightest tool in the shed, trying to bend a metal ruler. He realizes all that he can measure is the distance across, which if you have space inside your circle, you could actually write it inside of here. This diameter. Meter, we're only referencing something with a measurement. And I'm pretty sure dia somehow relates back to like across. Yes?
So, and then the little line is like the thing called the arc, or like, yeah, the radius, and it's half of the diameter.
Yeah, the little line is the radius. And it's half the diameter. And then, what's stem meant around? Circum, right? Like circumnavigate. Yeah, this is our circumference if you're talking about the distance around the outside. Be Mr. Smith today. So Kabila. I don't even know where he is. He just planning period right now?
So I'm just hanging out in the area.
As long as Mr. Smith's out there.
In the woods.
All right, so talk with your partner. Make a prediction if we can only measure straight. Do you have a guess of how that label, like what the distance of that label needs to be compared to a straight measurement that we can make? So talk 30 seconds or a minute, chat with each other. You're chatting with your partner right now, though.
Everybody has freckles.
No.
I used to have freckles.
Not on your face. Okay, we have time to chat everybody.
So I'm guessing that you would measure the diameter of the radius and then you multiply them.
10 seconds to wrap up your conversations. All right, so we can take our metal ruler and measure across, or this is actually bendy, but even though we still don't want to, like this would be bendy. But if I measure across, go ahead and label on your paper, this is right about 7 centimeters. I'm going to make your life easy, and we're going to call it 7 centimeters. So on our circle, yeah, so that then for us is the diameter. So that's the distance all the way across. Now, if I take that distance and kind of try to envision like making it flexible, how far do you think I could wrap if I start here and start wrapping around there? Or how many of those do you think it would take to get around the can? 4. Adrian? Adrian's holding up 3. I heard a couple people say 4. 2? You think 2 might be enough? How, if I took this distance, the diameter, and was able to wrap it around here, like how many of them do we think? So according to Adrian, he said 3 might get all the way around.
4.
Casey is angrily saying pi.
Oh, it is pi.
The formula for circumference.
Are we learning
No,
something
2.
new?
Have we talked about this?
I see one of my friends multiply.
How do we remember this? We're reviewing.
Crust is pie dough.
Crust is pie dough. The crust is pie dough. And the pizza crust is dough also. But crust is pie dough. So therefore, circumference, the equation we use is pi times diameter. So here, our circumference, our label that's going to wrap around there, is pi, which we know is 3.14, times our 7. It's at least 21. Anyone got a calculator? You can do this multiplication for me. What do you got?
21. It's like about 22. I have an answer.
21.939,
0.99.
so 94.
I got 95.
So close to that. We can round a different way, potentially.
I got 21.
I have 21. 21.9. I mean, it might be 9.5 because now whether you use the pi button on your calculator or type in the number 3.14, you will get different answers. So whether it could slightly, because the decibels, right? When you on the calculator, when you on the calculator hit the pi button, which is right here, right? Left hand side, there's a pi button. It is inserting all of that and more. It's plugging in the most precise it has, and it's got it in its program. So it's got a ton of decimal places. That's why you'll get a more precise answer, slightly bigger. Now, are you getting an answer in pi? Or a different question? So hang on just a second. If your calculator spits out your answer in pi, like you type in 7 times pi and it spits out 7 pi, excuse me, you need to go into your mode and change the setting. There's math print versus classic, I believe. Print and hit mode. What on the bottom of that page? What does it tell you? There should be math print and.
It's on math print.
And what else does it have?
Classic.
Is that it?
Yeah.
So if you get an answer stuck in pi, switch your mode off of whichever one it's on. So don't try to memorize which one does which. Just know that if you hit mode, you can switch what mode you're in between classic and math print. And math print, I believe, is the one that gives you the pi terms. It spits it out in pi. Classic gives you the decimal value. Or if you still can't get it straightened out, go in and type 3.14 or whatever. So, sorry, Layla had a question.
So it's best to use your pi button?
It depends on what the so sometimes the question says use 3.144 pi. So actually, that's a terrific question. Pay attention to what the test tells you to use. I don't care because I want you to make your own choices. But on the state test, because there might be a computer grading certain answers, if it tells you to use 3.14 and you use the pi button, you're going to get it wrong because your answer won't match what the computer's looking for. Does that make sense?
Yeah.
Yeah. So be careful, read, and see what they want you to use.
How do you select the mode?
I hit mode, and then go down, use your D-pad, like the arrows. Any questions on that? And as a couple people were complaining, you're like, we already did this. We're coming back to it to make sure we're comfortable with this, and then we're going to take it further.
Oh gosh.
Oh gosh, of course.
Oh goodness.
We're not going to do all that just because we don't have time right now. So I should put this down here actually. So we talked about rational versus irrational. Can you please on your paper, I'm gonna swap my screens again so that I can write this. We're gonna write pi is irrational. So that's not what I needed.
What is irrational?
We're gonna talk about that.
Happy you asked.
So please write pi is irrational. And what irrational means, if we break it apart, rational, well, ratio, this means it cannot No, that's unreal. So like imaginary, those are ones outside of like what we can operate with. So you're right, but those are called imaginary. Irrational is just something I can't write as a fraction. So 1/2, 1/3, 2/4, 3/4. All of those numbers can be written as fractions. 0.75. That is 3/4. But an irrational can't. Because pi, we know, is 3.1415. And you could write as many of these on your paper as you want. But then, and I'll write a few more, 926. It cannot perfectly come out to be a fraction with a number over a number. This doesn't work. So, because mathematicians don't like it when you tell them you can't do that, this mathematician Eratosthenes, I think it was Eratosthenes. Are they going to tell me who? Sorry, I try to keep straight what mathematician did what, but their names are all weird because they lived a long time ago. I forget who it was. Anyways, this math dude, yeah, seriously, this math dude, in 1650 BC, right? This is how old the idea of pi is. Got like, so that's BC, right? Before, we're talking like 4,000 years ago almost. So they started grappling with this whole like, wait, I can't make it a fraction, and people knew what fractions were and everything back then. So this mathematician wanted to make it a fraction. He said, you know what? I'm going to use a squiggly equals, which means approximate, right? Estimate, approximate. Pi is very close to 22/7. Will somebody with a calculator type in 22 divided by 7 and tell me what you get?
3.1428.
So if this is actual pi, well, it's good on the ones, good on the tenths, good on the hundredths, but then here we're off just by 1,000th. Bless you. Here we're off by 3,000ths, but then here we're off by 4,000ths the other direction, or 410,000, 400,000, something like that. This is really close. It's essentially 13 10,000ths away from being right. So if you need, I don't know when you would need it, but if you need to try to express pi as a fraction, this is as close as we get without using really big numbers. So like without using, something in the hundreds or thousands or something set up with that division. So that's just an approximation for pi. But again, this is a famous thing, so it could end up on like Who Wants to Be a Millionaire or whatever. Like if you're ever asked what's the fraction approximation for pi, 22/7. Because guys, think about it. 21/7, and this is probably what that mathematician did. What is this? Exactly 3. So then he was like, well, what if I bump this up by a number and try 22/7? Like, I bet he also tried 25/8, right? Because 24/8 is exactly 3. I bet he also tried 19/6, because that's just over, and this is the closest that we can get. Sorry, Joe, you had your hand up. No, but it's the main one we deal with. So other irrationals, just because you asked Joey, would be situations like what I'm dealing with in my other class. If we have what's called a non-perfect square root. Type that in your calculator. The radical button is the second function of x squared. So the radical means square root, not radical like surfers, but radical means square root. This comes out to be like 1.4.
Well, Jillian's going to calculate. I have it. 1.142135.
Hold on. 1.1421. Does it keep going? It runs out of screen. So there are certain numbers. You don't need to know this. This is 8th grade content, but he asked the question, so I want to answer it. There are certain numbers that when we perform an operation, right? This is an operation. The radical, the square, that's an operation. We perform that, and the answer is super messy. This is an irrational number. You don't need to care about that yet, but those are other situations where you'll find irrational numbers. Joey, this year, pi is the only one you really need to care about. That makes sense. It's just us layering on more math, like slowly layering stuff.
What does pi even come into use for?
It is, so let's define that. Write down on your paper, please, what is pi? Because Aiden asked the best question he could. And guys, I'm not exaggerating here. The majority of the world probably can't answer this question. Because they got taught circles as memorize this, memorize this, memorize this. And it wasn't about understanding. We invented pi. Mathematicians gave it the name pi. They didn't discover some stone sent down by the heavens. No, we discovered, we made it because pi is when you have a perfect circle, the circumference of the circle divided by the diameter. That's what pi is. Any perfect circle, if you measure with accuracy the distance to get around it compared to the distance to get across it, your answer comes out to be pi. Which the idea that you should get from this, that dot 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 means it keeps going, right? So if I put a real equal sign, I have to put a dot 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 to show that number's not done. Any circle, the distance to go around is essentially 3 times the distance to go across. So if we were designing a path, a walking path, right? And we knew how wide the field was, and we're going to do a circular walking path. That circular path will be about 3 times the width of the field, the length of the path. So we can essentially say circle around is 3 times across, but it's a tiny bit over. Other questions about pi or circumference or radius or diameter? Yeah.
Is it going to be on the test?
Yes. I could almost guarantee, I'm not sure what is on the state test. You're taking that test before you take another test for me, but it will likely be on there. Circles are a 7th grade content. Why? So if you were just writing down things you should be aware of, and then I'm going to come over to you, Kevin. Diameter, as we already talked about with our circles, right? You have this drawn on your paper. The diameter is twice the radius, because the radius is halfway across, the diameter is all the way across. We could also turn that statement around and say the radius is half the diameter, and then you definitely need to have on your paper that cross circumference is pi times diameter, or we could replace that diameter with 2 times the radius, and you probably don't have this written down. So when a problem only gives you the radius, you've got options. You can find the diameter and then go from there, or you can use the circumference formula that involves the radius.
Remember I would see this in the state test with pi, and I was what is this?
It's just a symbol used to represent a number that we don't want to write. That's really what it comes down to, guys. Mathematicians don't want to write this. Kevin? Oh, yeah, you're good. Now we're going to keep going, but you can copy notes from Brendan when you get back or whatever. Yeah. If your diameter is 1. So actually, that's a great example. If you want to put an example on your paper, if our diameter is 1, then the distance around the circle is 3.1415992. You literally just write pi. if your circle's 1 across, then your circumference, pi times that, well, 3.141592656. I used to know more, but then you just multiply. So here, to wrap it up and close this lesson, because this is what CPM wanted you to understand, here, pi is operating like a scale factor. We are scaling the diameter. So we're plugging in an input diameter with a scale factor, right? A scale factor is any multiplier. This is a multiplier to get our end result circumference. Any remaining questions?
So you just find out the diameter before you find out pi.
No, pi is always 3.1415. Like, you don't need the diameter to find pi. You need the diameter if we're looking for circumference, or if we're looking for radius. Pi day was over spring break. Sorry, we missed it. We were out, and we've just taken slightly long enough this year with stuff. I couldn't sacrifice another day, so I'm sorry that we didn't do anything special. We might do some special math celebration in April, like in this month and or in May. Now, like once we get beyond testing.
We should get pie on your birthday.
Maybe. I was debating whether I was going to come to school on my birthday, though.
Better than pi.
Guys, I'm honest with you. I'm debating whether or not I want to come to school on my birthday. Because as a professional, I'm allowed to take what's called a personal day, where you can take the day for whatever reason you want.
Whoa.
So, no, I love you guys, but I also have home projects to start taking care of.
And he also wants to relax.
Yeah, and I could like go kayaking or biking. Yeah, Jalen.
Relax.
Don't come to school because you're turning 30.
You're right. I will only turn 31. Adrian.
It's the big
That won't be
30.
enough for all of us, though.
But it's the big 30.
Squiggly line. Squiggly line. Squiggly line. Squiggly line. Yeah, I see a lot of people not squiggly lining. Alright, now I gotta use my dot camera because I want us to do this like all together. Now this is gonna be a little difficult depending on what size graph paper you have. I think most of us, you know, that's always like, it's always recording that even though you can't see the, there's always the picture in picture.
Can they see me?
Mm-hmm.
Oh, yeah.
Because the picture in picture screen.
My old math teacher would say you can never divide like a number and like you can never divide 3 by 2. Like they used to say like you could never ever.
Well, it can't happen cleanly. Is probably what they meant.
Like it's voice rate.
Sky, what's up?
Yesterday I saw Miss Freer at the library and she was like, "You guys talk a lot about me in your math class," and I was really embarrassed.
Are you serious?
She watches my videos?
Yes, she was. Cause she.
Why?
Like,
Alright, do me a favor. Try.
I don't talk trash.
Hey, well, yeah, of course we're not going to talk trash.
I don't know you.
Okay, here's what you're going for. We want to try to center our circle on the graph paper, so give me your attention on the board real quick. This tick mark and this tick mark can line up with your graph lines, but then these will end up in the middle of the squares, which is okay. But if everyone could please draw the big circle, if you're using this graph paper, like the 5-star graph paper on the edge, we'll all have the same size circle. Now, hold up. Here's what I need you to do then. So, I appreciate you working with me and following directions because I did not make these copy papers because I wanted to save some prints, right? We're over our print limit for the year, which I can keep printing, but we're going to keep paying for it. I appreciate you following my directions. Now, we're going to put squares inside this and outside this. Now, conveniently, this square pretty much fits if you use square 3. So you can use square 3 to essentially, yeah, you want the big circle. So this is why I'm asking you, please follow my directions. Then we're going to try to make a square outside of it. Now your task is to determine or estimate the area of both of those squares. Okay, I'm going to give you a few minutes. Your task is estimate the area of both of my squares based off this being 1. Okay, like one shaded square is 1. What is the area of the inside square and then the outside square? And then we will all come back together. So go right ahead. Your inside square, you should have used square 3 on your shapes template. If you use circle 1, square 3 will fit inside of it. If you use circle 1, square 3 will fit inside of it.
I'm gonna have to do a square 4.
Well, if you're using the 5-star graph paper, it should.
Wait, what goes on the bigger side?
You just have to use lines. Like, you just have to draw straight lines. So your top and your bottom, if you're using this 5-star graph paper, should be able to line up with lines. But then your left and your right doesn't. They're in the halves.
I'm using 5 stars, but it still doesn't fit.
Yeah.
Well, are you on the back of it? These squares are smaller on the back.
Well, it's no. It almost.
So this will work. You're just going to get different answers. Okay, this will work. You're just going to get different answers. Adrian?
What'd you do?
Weird question that's not really related, but I've had this question forever.
Okay, is it just for me or is it for the class? Do you want me to come back to it or do you just want to ask it? Okay, I mean, what's your question?
If you have a decimal that repeats forever and ever and ever, would that eventually equal 1 if you're on the number line? You're just getting closer and closer to 1.
A decimal that repeats isn't moving. It is where it is. The repeating is just getting more and more precise.
I know, but still, you would be getting closer.
Are you asking is 0.9 repeating equal to 1?
No, like
Give me a number example.
like any decimal that repeats.
Okay, so like a third, like 0.3 repeating. What do you mean is it getting closer to 1?
Say you're on the number line.
Yeah.
And you have a decimal that repeats. You're getting more specific. Each time you get more specific, you're slightly getting closer to 1.
We're not. We might be getting further away from 1, depending on what number it is. Take 1.3 repeating. 1.3 compared to 1.33 compared to 1.333, we're actually getting slightly further away.
No, like
We should talk individually. We don't have enough time right now to do circles and this conversation. I know what you're thinking, and I'm going to keep pushing those thoughts, but like, I think you might have a slight misconception, or I'm not understanding you correctly. But we gotta spend some time on this. If on the 5-star graph paper, I can easily count 1, 2, 3, 4, 5, 6, the first one that I shaded, and then I'm gonna go ahead and call this 7 because it uses like a bit of the bottom part. I'm gonna call this 8, probably. 9. Maybe using both these. 10, maybe. And then I have some slivers. Ooh, I could take this section and my sliver up here, call that like 11. This section and that sliver, maybe call that 12. I don't know, a little over 12 maybe.
Hey, where did you get that bigger square?
It's not on there, you just have to draw.
Straight lines. I just do straight lines. So that inside area is pretty darn approximate. My outside area, I'm going to cheat a tiny bit and use some highlighter up here. It's not actually cheating. I just call it cheating because it makes you guys react and then it's funnier. So I have 1, except my pen's not going to work now. So hold up. The easy ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20. Real easy. How much is this?
Like 1/2.
It's like a half, right? So 21, 22, 23, 24, 25. I think our outside's like 25. So if our inside square is like approximately 12, and the outside is approximately 25, how do you think we could make a guess for the circle area? If we counted all the inside square, but then we missed boom, 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 boom sections, and then we counted the outside square, but we had extra boom, 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 boom corner sections that we didn't actually need. So we know the outside area is too big, the inside area is too small. What could we do? If 12 is too small, 25 is too big, is there a way I could make a guess? This is when the mathematical idea of averaging values is very convenient. The average of something is when I have two things that I want to find, like, not the middle. Don't think of it as the dead middle. But, well, and if it's two things, you will find the middle. But if you have more than two things, you find the average point that could describe it, right? So the circle is in between the little square and the big square, like almost perfectly, right? By what we see, right? How we've drawn that, the circle's perfectly kind of nestled in between. So if we add up 25 and 12, we get 37, and we divide by 2, 15 plus another 3.5, 18.5 maybe? 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 Now, we have a formal way to do this, of course, because mathematicians like to formalize and create rules. To formally find the area of a circle, please write this down. We're going to use it on your homework and a lot. It's pi times the radius squared. Now, half the trouble kids end up in here comes from this. What this really means is pi times the radius times the radius. When you square a number, you're multiplying by itself. Think of finding the area of a square. The two edges are the same, so we multiply like 5 by 5 or 10 by 10. Like, it's a number times itself. So in the circle that we made, how wide was it? I can count from top to bottom and find out how wide it is. 5, right? 1, 2, 3, 4, 5. So if the radius is 5, or no, wait. If that's the distance across, is that our radius? No, so our circle that we have up there, we said the distance across is 5. What would the radius be then? 2.5, right? Half of that. So if we go to solve that, write on your paper, please, area equals pi times 2.5 squared.
Or 6.5. 6.25.
Yeah, that, when we square it, becomes 6.25. 3.14.
19.63495408.
Okay, we can just stop at the hundredths place. I appreciate your accuracy, but when we're working with pi, we're going to always end up with big old decimal numbers. So get used to rounding at the hundredths place. And then we would call this units squared because it's area. Right? Area labels have to be squared. So guys, while I do not like teaching you in the way of memorize this, I love teaching you, but I do not like telling you to memorize this. This is a formula that you're going to use a lot in your mathematical journey. Get it, like, in your head. Now, there's a way, like, I hate saying that, I do, but, like, on a test, if you can just pull it out of your head real easy, it's going to make your life easier. There's a confusion that people tend to have that I want to help with. The other formula that's very similar to this is when that 2 comes out here instead. Now, I do not want this to confuse anyone, but both of your circle formulas can involve the same numbers if you want. We, on a slide or two ago, said circumference is pi dou, right? And we also said that diameter, pi times the diameter was 2 times the radius. This is pi times diameter, just in a different order. So if you want to use the same numbers for each of them, area is pi times radius squared because area has to be squared. It's flat space. Circumference, 2 times pi times r. If you want to use those formulas. Questions? Now, a lot of times, we will let you keep your answer in terms of pi. So what that means is if I give you a circle and I tell you that the center of it, the radius of it is 5, and I tell you what's the area in terms of pi, and we don't multiply with your pi, square your radius and leave it. So this, what's 5 squared? 25. This area is 25 pi, if you're allowed to leave it in terms of pi. Which, these are way nicer than actually doing the multiplication and getting a nasty decimal that goes on forever. Likewise, if our area was 7, if our radius was 7, just 49 pi. So that's the easy way to do area. Okay, give me your eyes for 10 more seconds. Please bring me questions tomorrow. I want to know if anything we've done this week, if you're still struggling or unable to do it. I really want to start tomorrow with reviewing homework if you have any issues. Okay, but if we don't have issues, I'm going to keep moving on. So you've got to practice to know if you're having issues. Thank you very much.